Hello everyone and welcome back to the bug bounty course. And we're in our second phase here where you start hacking applications and having a go. So today we're going to be talking about web APIs. So essentially you open up your program, you scroll down to the scope and web API. What should you do next? That's what this video is going to cover. There's going to be a bunch of other videos along this same theme, looking at things like source code and recon and methodologies, but this is just about web APIs. And before you're like, Katie, haven't you already made this video? This is an updated web APIs video. This is as of 2023, as in the new OWASP API top 10. It's updated, it's new content, I promise. This video is very kindly sponsored by BugCrowd. A great hacker needs a great platform, and BugCrowd is the home of the hacker. They provide hackers with the best opportunities to make money, advance their skills, build community, and unleash ingenuity through their security knowledge platform. They provide distinctive educational content for hackers. You can rapidly pick up new skills through BugCrowd University or gain practical experience with one of their many monthly challenges. Or maybe you want to follow real hacking experts like myself as we cover methodology, shortcuts, and tools. BugCrowd has an entire level up series unique to the industry that covers all of that. So if you're interested in joining BugCrowd, head over to bugcrowd.com/hackers now and join the BugCrowd community. Thank you very much to BugCrowd for sponsoring this video. Okay, so let's get into it. What is an API anyway? How do they work? What do they look like? An API is a type of web applications that is really designed for other applications to interact with it rather than humans. So you're not supposed to be able to access an API directly. This may be intentionally as a way to provide a third-party app. The Twitter Developer API enables people to build stuff on top of Twitter, or it could just be a single API for a single application that's just in use. The idea of an API is really that developers can write one API, then reuse the same API for a mobile app, a web app, a website, etc., etc. It's write code once rather than writing it multiple times. And particularly for business logic and just plain old database applications, very common. As soon as you learn what to look for with an API, you will see them everywhere because they are what powers modern web. Everything from hardware, so your smart home stuff, APIs, to your social media apps, also APIs, to even email, an API. How can you notice an API? APIs will often use JSON. They might also use XML, and we'll talk about that in a second. JSON is this way to represent data in a text format, but it's specifically representing object-oriented data. It's this idea of objects and lists, which have objects inside of them, and everything is an object. And it has these key value. Looking on the side, a JSON object will always start with a curly brace, and then it will start with a key. So in this case, menu has 2 dots, and then the value of that. So in this case, another curly brace, which means menu is itself an object. So we return an object that has the value of menu, which has another object in it. It's important to become really familiar with reading JSON, because it's basically how every API communicates. So much so that, for example, for me, as somebody who works with JSON quite a lot, I don't need another reader. I can just read the JSON. Now, if you are new and you want a kind of easier way to parse all of this, I really recommend having a graph-based view. In the description, I've put a link to a website that can do this. You paste in a bunch of JSON, and it produces a hierarchical graph of what it looks like. And especially if you've got large GraphQL APIs where you've introspection on and it's huge, it keeps on crashing, GQL Voyager, big help. So there's several different types of APIs, and by far the most common one you'll see is a RESTful API. Now, RESTful used to stand for something. It used to stand for Representational State Transfer. It's not really what it means anymore. It defines the specific kind of flavors of APIs, and certainly I'll explain this in a minute, but just know it is by far the most common. What you may also see is a batched API. So this is often a RESTful or GraphQL API, but instead of sending the API request itself, you actually embed a bunch of requests into a single piece of JSON. I'm not going to talk too much about this, but this is really common in mobile applications. Again, it's not super important that you know what it is, but it's out there. GraphQL, which is probably my favorite thing to hack at the moment. So GraphQL is this new technology that instead of defining what we'll see as CRUD endpoints, you have a single location and you have whoever's accessing the API write queries like SQL, but its own little query language. And the reason why I like hacking them so much is that people really aren't sure how to secure them yet. It's still something that people are learning, and therefore you find a lot of bugs in them. A lot of the time they've not quite been configured correctly, they've not got the same access control, simply because people are less familiar with it. Now, SOAP APIs are the complete opposite. GraphQL is the new hot API that everyone's implementing. SOAP API is the dying legacy application that's still in use because it's somehow holding together critical national infrastructure. So SOAP uses XML instead of JSON, which is similar in some ways, but very different in other ways. This is primarily used in legacy applications. It's not always used in legacy applications, but primarily it is. And they can be really great places to hack because legacy applications are full of security vulnerabilities. And often a company might have found out about it maybe 5 years ago and have just been completely unwilling to fix it. You can also have GRC APIs, and I'm not going to spend time talking about them at the moment, but just know that they exist. RESTful APIs. RESTful APIs have this really defined structure, and this structure relates to CRUD functionality. A RESTful API has always 5 different routes per resource. Now, a route is an endpoint, is a piece of code that does something. We make a post request to /resource name that creates a new resource. We can read get /resource name /ID, or we can remove the ID. Removing the ID will fetch all of those resources, and keeping the ID will only fetch one. Again, we can imagine the resources can be anything. If we're on YouTube, they might be videos, they might be comments, they might be playlists, etc. We have update and then delete. Now, update and delete are a bit different. Update and delete by the standards should use put and delete as their HTTP verb. But if you've been looking at web applications for a while, you'll know that most of them are get and post, not put and delete. And because of that, a lot of APIs will often have a hacked way around it. Maybe it'll be a post request to /edit or a post request to /delete. Now, RESTful APIs really do have this defined structure, and while it may vary on update and delete, the create and read are usually exactly the same. You can really easily predict new endpoints simply by knowing what an application does. So YouTube's API might have something like get video ID. You can also assume that delete video ID exists. And if YouTube has videos and it has comments, maybe get comment ID exists. And you can see how quickly this can explode outwards because a single resource type is going to have 5 endpoints, so 5 different things for you to test. A API may have hundreds of resources depending on how large it is. Now, these are really widely used, and now I've pointed them out, you're going to see them everywhere. But some might be more custom to an API, and this is why quite a lot of traditional recon doesn't really work on APIs, because you need to know how this API is developed. And they usually return JSON. Now, you might be familiar with developer APIs thanks to 2 recent, very controversial examples of these. Developer APIs are usually fully documented APIs that are designed for third-party developers to build on top of things. So, for example, for Reddit, they have third-party applications that aren't made by Reddit, or on Twitter, maybe you've got an academic who's using Twitter as part of their research. This is what I meant by developer APIs. It's intentional. Now, developer APIs are probably what you can see most easily because you can just Google developer APIs. But APIs exist everywhere, and certainly just because an API is undocumented doesn't mean that it's not an API. It means it's really hard to hack, it means it's a pain, but we like pains because if it's a pain to hack, it means we might be the only person doing it, and therefore we can find lots of bugs. So the stages of hacking an API, at least in how I approach things, is step 1, find endpoints. And reconnaissance is one of the most challenging things about API hacking. You don't need to find everything though, you just need to find enough to start doing the other stages. I think that's really important because traditional recon, things like subdomain enumeration, doesn't really work on APIs. Fuzzing can work, but it often is very context dependent. And if you watch my full video on API enumeration, you'll see why this matters so much. But this is hard because the APIs that we want to hack are undocumented. And we need to find something that nobody else has looked at before. So we have that extra level of challenge. Once I know what I'm hacking, I'll test for issues between the API and UI. A lot of people overcomplicate API hacking and they're like, oh, it's this brand new thing, it's this hacking APIs. Initially, just do your same litmus test you would do for any other web application, because at its core, an API is just another web application. Look for cross-site scripting, SQL injection, whatever other acronyms you want to hunt for. Check that API, if you access it directly, doesn't have, say, WAF filtering. After you've tested for those kind of initial bugs, then test for your API-specific bugs. And if you test nothing else, always test for access control issues. They are by far, by a significant amount, the most common API bugs. Whether that's access control at the object level, so think about IDORs or BOLAs or whatever you want to call them. Whether that's access control on information disclosure, so it should be private, but it's not. Whether or not that's access control at the function level. So if you've got a complex permission hierarchy, that's a great place to find access control issues. And then escalate. APIs are really great places to find bug chains and to actually use your bug chains. Account takeovers are probably the easiest critical vulnerabilities to find. If you are struggling to find a critical, look at account takeovers because that is where you want to go. Now, API keys, as in a company has accidentally committed an API key, is not really the same as API hacking. If you want to do API key hunting, you probably want a tool called Trufflehog that can find those automatically from a GitHub repository or a GitHub user. Separate types of hacking, separate considerations. Recon. I made a full video where I went into API recon in quite a lot of detail. And I'm not going to go over a lot of it here, but I am going to update essentially what was in that video. I might update the full video, maybe if something really big comes out. But for the moment, if you've seen this video, this is going to just be like a little addendum. If you haven't seen that video, watch that video. RESTful APIs. RESTful APIs are the most challenging to enumerate because you need to guess the resource names, or they're sometimes called routes or endpoints. You need common resource names. A lot of people ask me, what's the best word list for API hacking? And I tell them the dictionary, because genuinely an API endpoint or a resource can be called anything. Using a list of common RESTful endpoints is a good starting place, but it really can be anything, and it can often depend on the kind of verbiage that your target uses. Now, some people have published targeted word lists to some different programs. If you can find a more tailored word list, start there. Even better if you can find just documentation. But if they've done custom resource names, you have to just understand the functionality of the app and start to curate some likely endpoints. For example, if the API powers a forum, you're going to try post, you're going to try reply, you're going to try whatever. Now, if you want to fuzz this automatically, I really recommend a tool called Kite Runner because it has context-driven fuzzing for APIs. You can also use FFUF and an API word list. Now, the one I've got on the slides here is a GraphQL word list, but it can really be helpful for a bunch of different APIs as well because it tends to have more generic names than just what you'd have for a GraphQL endpoint. And GraphQL hacking in general, GraphQL enumeration, is often done with introspection. I'm not going to go into that. You can watch my full video on GraphQL hacking if you want to see that. It's in the same playlist as this video is in. My favorite way to find bugs, though, is to just click buttons. The best way to discover APIs is just clicking on buttons. It's very easy to go, okay, I'm hacking Zoom, it's a meetings app, so I'm just gonna see those API endpoints. Zoom has third-party apps on their store. Zoom allows for room booking if you have an iPad in a room. Zoom has the whole whiteboard functionality, and each of these has API endpoints, and that is endpoints for you to look at and for you to hack. Go into those lesser known features, try and understand your target, what the intended functionality is, but that kind of power user functionality. Each of these is going to use the API and be victim of API issues. There's nothing special about them. Now, if you find this quite overwhelming, you are not alone. You can start to use something like a spreadsheet or your note-taking to try and understand things. Me personally, and I'm not recommending for this approach, but me personally, I tend to just hack chaotically. I'll just open up like burp, repeater tabs, and hack that way. A lot of people don't like that though, because it can be probably quite validly very overwhelming. So they might want to have a spreadsheet of just list of routes and what they've tested. And that's another approach that you can use. API-specific security issues. What are we actually looking for? The OWASP top 10 might be something you're already familiar with, but the OWASP top 10 also has a little project called the OWASP API top 10, which has the top 10 API-specific security flaws. Now, as bug bounty hunters, we're not necessarily going to find all of these, and we're not necessarily this list, but I think it's still worth talking about, and it was recently updated. So let's take a look. So this is the OWASP API top 10. So first issue, API 1 is broken object level authorization. This essentially means you can edit or delete or post a new resource on somebody else's account. So let's think about users on Twitter. You could edit someone else's tweet. You could delete somebody else's tweet, even though you wouldn't be able to normally do that. Super straightforward vulnerability to find. We'll use something called the cookie trick. I'll go over that in a second. But probably one of the most common security issues in APIs. I see it all the time in disclosed reports, but also just people talking about API flaws in general. API 2 is broken authentication, and this covers a range of different bugs, but is this idea of the authentication mechanism isn't working. That could be OAuth, that could be missing brute force, it could be JWT issues, it can be anything, but it essentially means that whatever's providing that authentication is broken. Now for APIs, this is particularly helpful because APIs often have multiple different ways of authenticating for different scopes of an application. So one application might use one type of key, another application uses a different key, and then a third application requires both of those keys. It depends on how the API is set up. In particular, looking at something like JWTs, JSON Web Tokens, which is a type of token that encodes JavaScript, is very helpful. API 3 is broken object property level authorization. This is the idea that the broken access control isn't on the object level, but on the property of that object. Let's say you were looking at an API where you can view user profile information of other users. You shouldn't be able to see their password in that information. Maybe you see their username, their avatar, the date it was created, but not the password. And this includes both editing and viewing. So this used to be called mass assignment. API 4 is unrestricted resource consumption. Not something that's typically rewardable in a bug bounty program because it covers things like DDoS attacks and also application level DOS. It depends on the program whether or not that's accepted. Essentially means you're able to consume all the resources that should be available for legitimate users. API 5 is broken function level authorization. This is the idea that you can do an admin function as a regular user, but also includes being able to do something horizontally as well as vertically. So if you're testing an API that has the idea of organizations with users belonging to organizations and those organizations having objects, an admin of one organization shouldn't be able to do a function of a different organization. They shouldn't be able to edit something they don't belong to. API 6 and API 10 is this idea that APIs belong to this flow of data. So unrestricted access sensitive business flows is this idea that you can use the API to cause some business logic error further downstream, while unsafe consumption is when the API uses another API. You might be familiar with this as like prompt injection, for example, where a API will just trust an LLM application to do something. Server-side request forgery, I'm not going to talk too much about this, but this is exactly the same as your typical API, the OWASP top 10 issue is exactly the same. API 8 is security misconfiguration, and much like broken authentication, it covers a range of different sort of security issues, from intentionally turning off security features to a developer messing up and not implementing a security feature correctly. In terms of what we will actually look for, we tend to focus on API 1, API 2, API 3, API 5, API 6, and API 10. Access control. I spoke about this. This is API 1, 3, and 5. It is shown at these three different levels. The first is at the object level, being able to edit an object that does not belong to you because the authorization check is missing. Any kind of API where something's been automatically generated, this is super, super common. If you want more information on actually hunting for these, you can see my full IDOR video, which I've left in the description for you to check out. We then have the property level. So this often comes out by information disclosure, and you want to be thinking about what needs to be like more information. For example, when you change your password, you want to provide your old password, but this can also appear as not needing your old password to change your current password. Commonly though, it's information disclosure, it's an API returning too much information. This is not a particularly hard bug to hunt for, but it can be quite difficult to find because you really need to understand your target very deeply to understand what they care about. And then we have permissions. Now, if you hunt for specifically in a bug bounty context, you're looking to get into bug bounty, I really recommend looking at permission issues, because a lot of applications nowadays, and in APIs in particular, have really complex hierarchies with tenancy applications. So where you have organization 1, organization 2, organization 3, and then you have users within that organization. And those users have different permission levels, and those permission levels might be user defined, so a user can create a bunch of permission levels. It gets really complex. Well worth looking at. Really good place to find bugs, because if you can break any of that, it's a bug, and it usually is a P3. And this can be both horizontal and vertical, so don't always look for doing admin actions. Sometimes it's about doing something at your current level, but to an organization that you don't control or a user you don't control. Now, the way I check for a lot of these issues is by doing the cookie trick, and I've explained this before. Again, I'll leave a video link so you can watch it. Essentially, we first need to check for authentication. Does this endpoint require us to just be logged in, but not necessarily be logged into the correct user? Step 1, create an account, log into it, perform a bunch of different requests, get a bunch of API endpoints, go into each request, remove the cookie line, and this tells the web application to treat these requests as they came from no particular user. If anything happens to our account with this cookie removed, it's a vulnerability. Now, if we want to check for authorization, that cross-account stuff, we're going to create two accounts, account A and account B. Again, perform a bunch of requests, go into all of the account A requests, and change it from account A's cookie to whatever's in account B's cookie. Now, if they cause something happen to account B, not account A, now check, have they caused something to happen to account A even when using user B's cookie? That is a vulnerability. Now, if you can affect user B with user B's cookie, that's not a vulnerability. You've logged yourself in as user B. unless you can generate the value of that cookie without the password and without the logging in mechanism, it's not a bug, it's not a vulnerability, you will not get paid for it. I promise you, a program is not screwing you over by doing this. You've misunderstood this particular trick. Essentially, we're taking a request made by user A, changing it to use user B's cookies and seeing if it still works. So the really easy way to do this is by using a tool called PwnFox. I have a full video on PwnFox coming up, so if you want to see this in use and how to set it up, I really recommend it. But it's essentially the idea of Firefox containers, but it automatically colors the requests in burp. So anything you do with account A will be colored in pink, anything with account B will be colored in green, and you can very quickly see whether or not it's breaking the authorization. Now, I personally don't recommend something like Authorize to do this automatically. I really like to do this manually, and I've had the most luck doing this manually. I've found that my mileage varies when using automated tools, so I personally don't recommend that. Information disclosure, as we saw previously, can range. Sometimes it's PII, and then other times it's like more technical. PII and allowing read access for something that should be private are by far the most common in APIs. That's not to say you don't get error messages, and that can tell you a bit about like what software is running. It happens, but access control issues, PII, really important. In fact, I did actually find a vulnerability once that I was looking at the API. It was like an edit, like an update, put API request. And I noticed that while I couldn't do that, it was getting me a 403, I could actually read the information of a resource in the API. Apart from that, information that I was reading was a private piece of information, so I could still read it even though I couldn't edit it. It happens. Keep an eye out for that. A lot of the other issues I tend to find are in business logic. This is very hard to teach you how to find. I'll be honest, I've not found a good way of teaching business logic errors yet, and I've already made videos on it. But business logic covers a broad types of vulnerabilities that are all about, should this really be correct? Is this really how this is supposed to work? But a lot of time with APIs, you'll find integrations with third parties. So maybe you're looking at, I don't know, a kind of system design for developers. It'll integrate with Jira and then offer Jira tickets. Maybe it will have payment accepted via PayPal. Those integrations can be great places to find business logic issues. Any kind of complex flows you want to think, can I break? Now, while these are thinking API-specific security issues, I really want to stress that APIs really aren't special and you shouldn't be afraid of them. They are, at their very core, API web applications. I still use Burp. I still use Burp the same way I do it for any other application. I'm still looking for cross-site scripting, SQL injection, CSRF, and other examples. If you go to API Security IO and read through some of the vulnerabilities, you'll very quickly realize that these are not API-specific issues. They are just same old vulnerabilities. Now, in a mobile environment, we're going to see more batching APIs, and APIs are very common in mobile apps. So if you're not sure where to find an API in mobile apps, and I explained this earlier, but essentially you have an API which is then telling them what request to another API that it's actually coming up with. And you can see an example here where you can see this list of operations which have an API endpoint, and then it says post. So it's a post request to an API endpoint. Here are the headers, here are the body of the request, etc. So that was just a very quick introduction to API hacking. I could go on about API hacking. I'm going to do a demonstration as a follow-up to this video, so you can have a look at what this actually looks like in practice and how I approach API hacking from a practical point of view. If you're still not sure about API hacking, I have linked on the thing on screen, which has the 2 videos. the playlist, everything API hacking. You can dive into every video I've made on API hacking. But I really want to stress that they're not that special, and you can totally start API hacking today. Like, there is nothing special about this. Go ahead, have a go yourself, and I will see you in the next video. Bye, everyone.